You ever stop to think about what actually happens in that split second after you hit send on a Gmail? I mean, it feels instant, right? Well, today we're going to pull back the curtain on one of the most massive systems on the entire planet. We are going to architect Gmail right here from the ground up, just like you'd have to in a big time system design interview. Okay, so to really get our heads around this challenge, we have to talk about scale. And I'm not talking thousands or even millions. We're talking billions, billions of emails every single day. Just try to picture the kind of engineering it takes to handle that constant, nonstop tsunami of data. All right, so let's put you in the hot seat for a second. Imagine the interviewer says, build me a global email service for 1 billion users. I mean, where do you even start, right? Well, that's the exact question we're going to tackle together today. So here's our game plan. First, we'll set the ground rules, our requirements. Then we'll sketch out the high-level blueprint. After that, we're going to follow one email on its wild journey through the system. We'll tackle the really hard problems, search and scale, and then we'll get into the juicy stuff, the design decisions and trade-offs that make it all work. All right, first things first. You can't build a skyscraper without a blueprint, right? So before we write a single line of code, we have to know exactly what we're building. In system design, this is all about defining our requirements. And let me tell you, this is the most critical step. Everything, and I mean everything, we do from this point on comes back to these ground rules. And these requirements, they basically come in two main flavors. You've got your functional requirements, that's the what. What does the system do? The send button, the inbox, stuff you can see and click. Then you have the non-functional requirements. That's the how well, how fast is it, how reliable is it? It's like a car, right? The stereo is a functional requirement, but its 5-star safety rating, that's non-functional, and you absolutely need both. So for our Gmail clone, the core functional stuff is pretty much what you'd expect, right? You got to be able to send an email, you got to be able to receive one, store them. You need to see your inbox and folders. Oh, and search. You have to be able to find that one email from 3 years ago. And of course, handle attachments. This is the bare minimum, the absolute table stakes. Okay, now for those big promises, the non-functionals. First, high availability. Email is like a utility now. It has to be on always. Next, low latency. When you click on your inbox, it needs to load like snap, right now. And maybe the most important of all, durability. We cannot lose people's emails, ever. Seriously, in system design, losing data is the cardinal sin. You just don't do it. Okay, so we know what we need to build. Now it's time to figure out how. Let's drop the blueprint. We're going to zoom way out, take that 30,000-foot view, and see how all the major components are going to talk to each other to make this thing work. So at the very front door, we have an API gateway. Think of it as the bouncer, directing all the traffic. Once you're inside, we've got a whole team of specialized microservices. Each one has a specific job. One handles authentication, another handles your mailbox, another one powers search. And the glue holding it all together? A message queue. It's kind of like the central nervous system. And all of this sits on top of a really clever 2-part storage system. And that split storage layer, that is a total game changer. This is probably one of the most important decisions in the whole design. So let me ask you this, just like an interviewer would. Why on earth would we split up an email's metadata, the sender, the subject line, the date, from the actual body of the email? Why separate them? And here's the brilliant answer. When you split the data, your inbox loads insanely fast. Why? Because all it's loading is that tiny, lightweight metadata, just a list of subjects and senders. We only go and fetch the heavy email body with all the text and images after you click on it. This is a classic trick for making systems feel super responsive. You send the smallest amount of data possible at first, which saves a ton of bandwidth for everyone. All right, our blueprint is ready. Now let's see this thing in action. We're going to bring this machine to life by following one single email on its epic journey. We'll trace it from the moment you hit send all the way to when it lands safely in your friend's inbox. Okay, so you hit send. What happens? First, your email goes through the API gateway, gets its credentials checked. Then, to make you feel like it's done, we immediately stick a copy in your sent folder. Boom. But here's the real magic. The system then puts the actual email into a message queue. This is huge. It means we can handle the complicated delivery process in the background, asynchronously. This way, even if 1 million people hit send at the same time, the system doesn't crash. It just adds them to the queue. Now, what about receiving an email? Well, this flow is all about perceived speed. When you open your Gmail app, our mailbox service goes and grabs only that lightweight metadata we keep talking about. It sorts it by date, and bam, it's on your screen, almost instantly. We don't waste time or data fetching the full email until you actually tap on one to read it. It's an awesome trick to make everything feel blazing fast. Okay, so sending and receiving. Check. That's working great. But now it's time for the really hard problems. The stuff that separates a good system from a great one. How do you search billions of emails instantly? How do you filter out all that spam? And how do you scale this whole thing to work for everyone on the planet? You know how Gmail search feels like actual magic? Well, the secret sauce is something called an inverted index. Think about the index at the back of a textbook. Instead of reading the whole book to find a word, you just look it up in the index and it tells you the page numbers. That's exactly what this is. The system pre-builds a giant index, mapping every word to every email it appears in. So when you search for meeting, it's not reading all your emails. It's just doing a super fast lookup in that index. It's brilliant. So how do we scale for 1 billion users? It really boils down to 3 key things. First, all our services are stateless, which is a fancy way of saying we can just add more servers whenever we need to, like cloning machines. Second, we partition our data by user. This is key. It's like giving every user their own personal filing cabinet. So when you search, we only look in your cabinet, not the entire warehouse. It's way more efficient. And third, we cache all the stuff you use a lot, like your recent inbox, to make it even faster. All right, we are in the home stretch. To put that final polish on our design, we have to talk about one of the most important concepts in all of engineering, trade-offs. Look, no system is perfect. Building something for the real world means you can't have it all. It's about making smart compromises to be great at the things that matter most. And listen up, because this is where you really shine in an interview. These are the big trade-offs we're making. For example, search results are eventually consistent. That means a brand new email might not show up in search for a few seconds. And that's okay. We're trading instant perfection for a more resilient system. Another one, when you delete an email, we don't really delete it right away. We just mark it as deleted. These aren't bugs. They're intentional choices to prioritize speed and reliability for everyone. So let's wrap this all up. What did we do? We designed a system using stateless services that can scale out. We used asynchronous message queues to handle huge bursts of traffic. We split our data with NoSQL for metadata and blob storage for the bodies. And by putting all those pieces together, we've created a blueprint for an email service that is scalable, highly available, and super durable. And there it is, a system designed to handle that daily tsunami of billions of emails. But, a design is never really done. So I'm going to leave you with a final thought, a question for you to chew on. Looking back at everything we built today, what's the one trade-off you might have made differently? And more importantly, why?